You turned it off. Are we live right now? Because I'm not able to see any footage over here. Yeah, now we are. Hey guys, welcome back to another live stream, and today we're gonna be working on this actuator. So we're continuing where we left off exactly during the last live stream. We had to turn off the last live stream because we were missing this, a very narrow two-faced fastener. This plier was missing, and that's why we couldn't find it anywhere in our lab. So hopefully you have this. It's a really narrow one, and this is what you're gonna be using for the USB-C to CAN module, and we couldn't find it anywhere in our lab, and that's why we had to wait like a whole day to start working on it again. As well as today was pretty busy in general for us. We had some other course to take care of, so we were not able to continue any more work on this. So today we are starting right from where we left off yesterday, exactly from there. So today our goal will be to flash the code to this and test calibration. So if that is successful, which we hope it is, then I will calibrate all of the other actuators which we have over here. We'll make sure once again that the soldering connections are perfectly made, because before assembly we do not want any short wires before assembly. And once these two things are confirmed, we'll start assembling the upper body, hopefully in today's live stream. So yeah, let's get started with this. Yep, so today we are moving on to the more exciting, definitely more exciting parts in the series. So if you have been following along, thank you so much for supporting these live streams. And today hopefully we get to see some motors moving, and hopefully everything turns out okay with the connections we have made so far. And if these actuators end up working, we're gonna assemble the upper body in today's live stream. So first up, we're gonna make sure to give the signals to all three motor coils, the winding A, B and C, and we're gonna provide those connections by using this motor controller. Now there is no documentation or tutorial online on how to do this, so we're gonna be doing this today, and if it ends up working, I'm gonna make a video on it, dedicated video, in which I'll briefly go over how to do this, everything you need to solder on these motor controllers, and some tips and tricks I have found to make this more reliable so that there are no short connections anywhere on the motor controller. So yeah, now to start off, I'm gonna need some power cables, and yeah, can you pass me the some cables so I can crimp them and make them ready? So I think a good color for that would be black. We have this 14 gauge black and white wire, and to get power from the battery, I think we should make it white and black. And then for the winding signals, A, B and C, I think we need to make all of them black, and we need to provide sufficient length of wire. Let's say this much, I'd say this much is good enough, and I'm gonna just make it a bit more bigger so we can because what I'm gonna do is I'm gonna attach these connectors so we can keep it as I think this much should be okay then. Okay. And we're gonna need more of these wires later on, because we only have like so much to go around this time, and we're not gonna be able to go through all of these encoders with the wire we have. So we're gonna have to grab some more of the 14 gauge wire. The goal with this is of course to only get one of the actuator working, and then the process once again is the same for the remaining actuators. So hopefully this is the first one we're going to be testing, and it's going to be live, and if it ends up working, we're going to repeat the process for the rest of the actuators. Have you seen how these they latch onto each other?
Is there not exactly, but we can very quickly see that first of all.
Before crimping that, we need to make sure that these wires will attach together. They're called power pole connectors. Let's take a look. Meanwhile, I'm getting some wire ready to get power from a lithium ion battery we have. It's an Ingo battery, and I'm sure many of you will have this battery lying around in your lab somewhere. And I am gonna attach, I think for the power supply as well, we can maybe make some sort of connectors. So it's a
I think it very easily just goes in.
the same, the exact same one.
The exact same ones, yeah.
Okay, so I think we for power cables as well, we can make some sort of connectors. So it's easy for us to attach them to the remaining actuators as well, so we don't have to solder everything.
If you wanna crimp, you can pick these. And do you wanna cut it first?
No. So this one is gonna go to.
The white one is live and the black one is ground.
No. So this is how I'm thinking of making these connections. So we're gonna attach it over here, and then here I'm gonna attach it to that wire unit we made that goes in there with the thimbles.
Got it.
And I am able to see that over there. So
so for these connections, obviously we need to have wires which are connected here.
Yes,
so
and then they need to have these on the other end.
These are what, like 16 gauge?
No, yeah, these are 16, but we can add 14 gauge over here on this end, and then we can just join them through connectors.
So I'll need to add connectors over on these, right?
Yes, all three of them.
Let me just crimp them.
Guys, we're moving really close to testing this motor, and if there is an issue, we're gonna troubleshoot it, and one way or other, we're gonna get it working today.
Yeah.
Someone dropped a like on the video. Thank you so much for dropping that like. Helps these live streams a lot.
By the way, our live stream just before the day before yesterday, our live stream, the music was too loud. Someone later on reached out to us and he let us know that the music was a bit too loud. On yesterday's live stream, we lowered the sound of the music a bit, and after when we were rewatching the live stream, we found out that there was no music at all because we lowered the sound too much. So today we just slightly increased the sound, and hopefully today the music sounds just okay compared to our voice. Obviously we cannot we're not able to check it right now. After the live stream we will review it once again and see if the sound of the music was okay.
So we're gonna have to desolder these wires from this buck converter.
You can show it that we're getting these wires from an old project.
Yep, so this is an old project. I've shared this in earlier live streams, and we are having to desolder this wire. This is the wire we're gonna use to supply power to the motor from the battery, and I'm gonna desolder this wire really quick from this buck converter over here.
So Reg left a comment. It's perfect now. So I think he's referring to the sound of the music. Thank you very much. Thank you very much. We had to lower the voice yesterday, and we lowered it too much. So yesterday there was no music in our live stream, but today, once we realized that, we increased the sound a little bit, and today it sounds like it's fine. Thank you very much for letting us know.
And I think Reg is the one who left the like on the video. So Reg, thank you for supporting these live streams. You show up in every single one of them, and that's what keeps us motivated to keep making these live streams, sharing this information, documenting the whole process. And once everything is done and everything is ready and the robot is moving, I am making separate videos for all of these actuators, soldering process, everything, and I'm gonna make a YouTube playlist with summarized versions of these videos, because I've seen no one has documented the process of communicating with the USB CAN and soldering these connections, and any tips that might help with soldering these, because these connections are really close to each other. So I'm gonna be making a whole series on this once we're done with building the robot.
Yeah, right now we just want to sprint a bit really fast, because we want to assemble the upper body as soon as we can. We want to have a loose sort of a prototype that is able to move, and we're able to upload basic policies to it. We're sprinting. Usually we're only working about 4 to 6 hours a day on this, even less than that, maybe even just 2.5 or 3 hours a day. But even during that time, I think our progress is it's decent in one day.
I want you to pull this wire.
Okay.
Keep pulling the here. Let's try to desolder this. Reg always has the same avatar. I think
yeah. This time also the avatar is the same as before.
I don't know the mechanics of exactly how the algo decides what avatar to give, but Reg, you have the same avatar like before. It has got the really cool red cape going on.
Is it a coincidence? Because I would imagine if it's decided by an algorithm or a code, it's just like a random code which assigns characters.
We had a different chatter yesterday, and he
had a different avatar.
He had a different avatar.
But that's interesting. How does it keep? How does the code decide which avatar to give to which comment? Because from my understanding, at least as much as I know about code, it should be random.
No, I think it can be like based on names or the first letter in the name.
Yeah, that could be the case. Yeah.
So if someone with the first letter R comments again, maybe he will get assigned the second character in a class or a group.
Yeah, could be.
I mean, there are so many ways to like go about it.
Yeah, it is a paid plugin, so I obviously it's the code is gonna have a little bit of depth to it. So I assume there's a lot of characters, and the algorithm which decides which character goes with which comment is also dynamic. So if multiple people with the first letter R comment, I think not all of them are gonna be the same.
Yeah, we're gonna get to test this if once we have more live viewers, which will be hopefully soon. But it's so cool that we got to see the plugin working.
Yep. Alright, I'm just crimping the last one.
Yeah, I'm also gonna need you to crimp these connections as well.
Alright.
There was this bucket over here with a small like wire segments. Like
yeah, it's over here.
Wire junk laying around. This one. I'm gonna cut this wire to size, and we're gonna attach it to the motor controller.
So this is, I think, our 6th live stream.
Yeah.
Yeah, for the future of this channel, or for this live stream, we had some interesting ideas which we by the way, the category is now science and technology. So
Yeah, I just changed it.
yeah, so for the future of these live streams, we had some interesting ideas. There's obviously many different ways we can go about it. We were thinking how to make it a bit more fun. And one idea we had was to have our hacker friends, or people who are just into software or building cool, fun hobby projects, just for an hour or two, if we all gather around a table and we're just having chat about some topic, maybe traveling, politics, or different countries, or economy, any topic, while we are building the projects or working on our own hobby projects. Kind of like a cafe get together, but on a live stream. So that was one of the interesting ideas we had. Let's see, maybe sometime in the near future we'll try something like that.
Yep, so having guests on, that's probably the next step. But it's gonna be a difficult job finding
No, I think
interested
I
guests.
don't
in-
think it'll be that difficult.
Yeah,
I don't
and-
think, no.
Yeah, and
I think there's a lot of people in any country. There's obviously many in San Francisco, US, that are just have hacker houses, and they just spend time together and work on their products. And I think there's many in Japan here as well. There's hacker houses I know of in Japan, where people just young folks, university students, they just
you know what might
spend many days working on projects.
something can help is if we can have them online, or if we can have them on a shared live session.
But would that be as cool
Remote.
as in person?
No, of course it won't be as cool as
So
that,
like
but,
in
but
person,
yeah,
have a table. In the middle of the table, there's all tools, and the 3D printer is
Yeah.
in the background.
yeah.
So anyone can code or work on their project while they are just having a discussion, and everyone's working, and there's just this live stream going on.
Yeah, maybe.
Just an interesting idea. We'll see if we can implement something like that or not in the future. We're still, I think, there's still ways to go before that. Currently, we're hardly finding just 2.5 or 3 hours or 4 hours a day just for this project. Ideally, I would like to work much more than these many hours on this project. I think if we were putting in around 8 to 10 hours a day just on this project, it would be finished maximum within 1 week. I don't see it taking more than a week.
Yeah, for sure. I think tomorrow and after tomorrow we should be able to give more time to.
Yeah,
Yes.
hopefully.
Hopefully, we have a really busy day tomorrow, but after that maybe we think we might be able to find more time for these live sessions, and generally working on this project.
The day after tomorrow, there's an event as well happening here in Tokyo, and the same one in Toranomon Hills.
Yeah.
So, if we have a long day free, we could try something really interesting, which is around like maybe a consistent 10 to 12 hour live stream. Just printing the project and finishing and assembling as much as we can. Because only tomorrow is a bit busy. After that, we do have some time. We'll see if we can sprint and put in more hours.
Yep. I think so too.
These 3 connections are made.
They're done.
Yep, these 3 are done.
Okay, I'm gonna solder these 3 to the motor controller, but before that I'm gonna solder the VCC and the ground pin for the
Can you
motor
push it a bit
controller.
further ahead so it's in the camera?
Yeah. Okay. Let's move it a bit
Like
a
this.
bit.
Yeah, this is just fine.
And after once we're done soldering the VCC and ground, we're gonna attach two more thimbles. They're not exactly thimbles, they're connectors, like the JST ones. We're gonna attach two more of those, and then we will be good to go to start testing if the wiring we've done, if it works. We're gonna try to push code and make the motor move. And once we troubleshoot that and we get everything working, the process should be fairly simple for the rest of the actuators. This is the ground. I'm gonna try and solder the ground connection first. Define first time boot up. We need to turn this to 1 because currently it's 0. I'll turn it to 1. Alright, what are the changes we need to make? Connect the motor controller to the computer via the micro USB port on the controller board. Micro USB port. Alright, so like I'll unbox that so that it's prepared as well. Okay, this is the connector we're gonna be using. I'll just unbox this. This is just like USB hub. I'm
Yeah.
pretty sure
Yeah.
it's really easy to find anywhere in the world. Connect the motor controller to the computer via the micro USB port on the controller board. There's one over here. This one. I'm not satisfied with the solder so far. The connection
You just made?
Yeah, I think we will have to
Desolder it.
not necessarily desolder it, but I think let's try pulling it and making sure it's intact. Yeah, seems okay. And we're also gonna make sure it's not jumping around, it's not short with anything around it. Yeah, I think it looks good. We're gonna grab the good old multimeter and we're gonna check for any shorts just to be safe. And then we're gonna attach connectors on this end, and then we should be good to go. So there is a short going on over here, but I'm not sure if that's built in. So I'm gonna grab another motor driver and I'm gonna make sure if that short is supposed to be there already. Yep, it is there by default. So it's an internal copper tracing for the PCB. And let's attach the three motor windings that we have just prepared over here. This tape has really started to give up. I'm gonna attach a new one now. Let me check something here real quick. shout out to this like double-sided tape. It has helped me the most with the project, with soldering different things together, and it's a good replacement for that Temu solder mini solder station. Just finished my coffee and let's get right to it. We're gonna try and move through this fast. I'm gonna apply a little bit of solder on the 3 of these connections for the motor windings. So we're gonna apply to a little bit over here. So I've left 3 bubbles over here for the wires to sit on, and then we have 3 of these connectors for windings, and I'm gonna place some solder on all 3 of these wires before putting them on here. It really helps with the soldering if you apply a little bit of solder wire on top of the copper inside wire. Okay, I'll just close this once again. Two more to go. I'm gonna place it here on the wire, and let's try to add some solder to it as well. Okay, now just one more to go now, which is this one. I'm gonna grab this and let's try attaching it over here. Really, I'm gonna need your help with this. We need to apply a lot of solder over here for it to like sit perfectly in its place. Just a second. Just a second here. Motor controller. I don't know if this is the one now. That's the problem. I think I might need to re-pull the repo once again, which I will do. ls cd into my directory and then clone the project once again. There I think we should also add a screen share for our what we're doing on the laptop. Yeah, but we're gonna need a different PC for that. So, but we're gonna be making a video on this regardless. So whatever code we push on this controller and whatever method we use to clone the repo, edit the code if we edit it at any point, whatever we're gonna be doing with the code, we're gonna be uploading that in a video later on. So it's gonna be a part of the series. Uh,
Yep.
I want you to grab this wire so I can.
Desolder? You want to desolder?
No desolder. I want to apply a lot of solder wire over here
Alright.
so the connection is like stable. So it's a good idea to use connectors for these as well. We will have to order more connectors because they are just not enough.
Yep.
But it's worth wasting connectors on these windings as well, so we can attach and detach the different actuator motors. So if one of them ends up not working, we can test the same code on a different actuator.
Yeah, because I think during assembly and disassembly, we're gonna be needing to reroute the wires a lot of times. So there's gonna be a lot of messing around with wiring, trying to take it through cleaner paths throughout the robot's arms and legs. So connectors will definitely help in that. That way we're not breaking things too much.
And the last one. Okay, we're almost there, guys. We're almost to the point where we try pushing code and try rotating the motor to see if it works or not. Is it like short with the resistor right next to it?
It could be, yeah.
Yeah, I need you to pull it slightly out towards the outside. So okay, now put it back in. I think it should be good enough.
Yeah.
Yep, so we have the 3 winding connections to the motor controller as well, and we have the power connections as well. It's really hot. I'm gonna have to wait for it to cool down. And this is not the most ideal setup once again, but it works. That's the most important thing. And you need to double check everything when you make these connections. As long as you're sure you're doing the right thing, as long as you're sure the connections are stable, they're not going to be jumping around, you can rush through making one actuator work, and then it's pretty much the same process for the rest of the actuators. But today we're gonna try and get this motor controller working. I am now gonna grab a heat shrinking tube. So this is something we use to make safe connections. So if we have exposed copper like this in our project, and it's like a 20-volt connection, and so we might end up risking a short circuit between these 2 wires. So a heat shrinking tube is a really nice way of making sure those connections are safe and secured. So while you are, I think we don't want to make a solid connection here. Actually, we're gonna make these connections with these connectors as well. So that way we will be able to detach this wire using the connectors, and we will be able to reattach it to all of these different actuators to test them each one by one. So yeah, we need to attach more connectors here for these wires. So 4 more connections, so we can use this again and again for different actuators.
You can have these 4, just crimp them, and
let me try and crimp them.
Yeah. So for crimping you will be using the 15 gauge part of the crimper, this one.
Okay.
I'll so just put it inside
Just
of
a
here
second. Just
like
a second.
this.
Let me cut it properly. And which section did you mention? The
This one, just put it inside like this, and now it's
the
inside.
15 one. Okay.
Yeah.
You release it.
Yeah, you just put it inside like this. Maybe even press it a little bit. Put it inside and just
Put the wire inside there. So this is a crimping tool. This is what we use to make these connectors work. So these connectors are pretty solid. They're not gonna fall off. So it's a really solid connection. I'm gonna put the wire in, and I am gonna try crimping it now. With most crimping tools, it requires a lot of force to snug everything together, and it's not coming off. It's a really tight connection now. We're gonna do the same for the black wire. You guys might have seen JST connectors as well. They work the exact same way. We're gonna put it in this hole over here.
just like this, downwards. It should be facing downwards.
And it should go in
Yep.
that like cave, sort of mini cave.
Yep.
Okay. It's a really nice latch, like it really holds on to the wire. Okay, I have attached the wire. Now it's time to brute force our way through this crimp as well. You need to apply a lot of force to and sometimes this happens. So the wire, it just broke off. So we're gonna try that again. We're gonna try making this connection again. I think we're gonna be needing like 3 more packs of this one.
Even more than 3, because in one pack there's just not too many connectors. I think we'll easily be needing 4 or 5 of these.
So once again, I am just gonna expose a little bit of wire from here.
By the way we keep tools in our lab is we always order just a little bit of extra, because we are usually working on just fun projects of our own or some other projects from time to time, and it happens more often than not in our case that we end up using some of the older tools that we have, some of the older parts in the latest project. It's always good to have the lab equipped with some of the components, because sometimes you just do not have enough time to wait for the tools to arrive. It's all especially in the case of a hardware lab, you always want to have extra tools or connectors or wires, so basic common things which are needed for a hardware lab. You always want to have some stock of those in your lab. That
Yeah,
is if
how
you want to
do we
continue working on the
pull
project.
this
Yeah,
out of each other?
just grab some from here. Just grab some from
These
here.
are like really attached together. So I'm gonna need one red, one black. So there's nice color coding going on over here as well. And I'm not sure which orientation is the right way. Is it this down and down?
Yep, down and down. And
Okay.
be very do not push too hard. Just slowly keep pressing.
I'm gonna keep pressing, and we're gonna wait for that satisfying click sound.
Yep.
I'm gonna bring it closer to the microphone.
Yep, there we go.
There we
Now
go.
try pulling it out. It
Yeah,
won't come out.
it's locked in there. I'm gonna make this second connection in the same way, and I'm gonna bring it closer to the mic, and let's hear that click sound. There we go. Yep, it's locked in there. So we're gonna make the same connections here on the motor controller. These connections are like excessive. You can solder everything in place together, like you can do hard soldering on these wires, but we want to be able to test with the battery on all of these actuators. That's why we're making these connections first. I am gonna try and move a bit fast with connections this time around. Let's try and cut this first so we don't have any excessive copper wire exposed. How's the software side coming along?
So I have an initial setup ready. I'll once these connections are done, I'll quickly bring my laptop over here and just quickly show everyone what I have done. And come to think of it, I did not necessarily need the STM32Cube IDE, but
yeah,
I could have just used VS Code, but I'm not sure because in the STM32Cube IDE there is a section for board selection. I think it's specifically only for STM32 chips. So still it's better to just use it. First time for using any software. After flashing the initial configuration from power cycle the board, unplug and plug in. After flashing power cycle the board by unplug and plug in again the USB cable. Then change the first time boot up flag back to 0.
This is the last crimp for now before testing the actuator. Let's hope it goes through without any trouble. Here goes nothing. Okay, we have this crimp nice and solid. Let's attach the ground and VCC connectors, and I'm gonna keep the color coding in line with what I've set on the other side. Lastly, I want one black connector. We really need more. Do we have any more of these connectors?
Nope, we do not. How are we gonna attach all the rest of the?
I think we're gonna have to like
Hard solder them.
We're gonna have to do some DIY stuff with that. Not especially like hard soldering, but
We do not want to do that hard soldering because
I think we can just make a. I don't know. We'll figure it out. Let's first try this one. Okay, so I think let me double check these connections, and then we're gonna attach everything. These look good, these appear to be fine. Same goes for the CAN cables and the ground. These connections are also fired, and of course none of the windings are short with each other. Okay, I think we're good to go with this.
Alright, let's remove the soldering iron from here. I don't think we need it for a while now. I'll safely just replace
You can
it.
You can try turning
Yeah,
it
yeah,
off
yeah.
as well.
I'll turn it off for sure.
And let's make.
We don't want to risk with such a dangerous thing. Um, just make some room for the laptop.
Just remove this as well. Remove this as well. Okay, this is probably what we have all been looking forward to. We've all been waiting for, and I am gonna let's attach these. How did they like join together?
Something like.
Are they even
Yes,
like
yeah.
meant to go together? I am gonna grab this and I'm gonna try and see if there's a female version of these connectors. Okay, we can try something. Yep, this is how they attach together. Once again, we made these connections through these connectors, so it's easy to detach any actuator, and we can use the same motor controller to test different actuators, or we can remove the battery from this motor controller and we can try testing different actuators using the same battery. So the battery we're going to be using, it's a standard Inco battery. I'm pretty certain if you're watching this video or if you're following this series, you must have heard of this brand. It's like a really famous brand, and we have a standard 20-volt battery. That's what we're going to be using to power this. So this is the ground.
So from the documentation, from my understanding, this motor driver, BLDC motor driver, it requires from anywhere from 12 volts to 25 volts. So this one is 20 volts, I guess, right? This one.
Yes,
So
this
we're,
is 20
we're just gonna be directly feeding this inside of this. We have ordered a circuit breaker as well to connect in between the power supply and the driver. However, we have not received it yet. It's still in the shipping process. So we're just gonna be directly attaching the power supply right now.
Yep.
So there's
V in and ground. Okay, let's hope we don't get any sort of sparks.
yeah, there's gonna be a light on this as well.
There we go. Wow, the motor just moved a bit. Huh? Why is it moving? It's making some beeping sounds. We have some loose connections here. Yep, I think that's the case. Just leave it like this. The motor is making some weird sounds, but as you can see, the driver is live. The motor, it's making a weird beep sound. And it just turned off now. So I think there is some issue.
Problem with the
Yeah,
connection?
some issue with these connections. We're gonna have to resolder them and I think we should reattach the solder wire. And then I think we also need to make sure these connections are stable as well. Yeah, they really look stable, but the power to the board, I think we might have an issue with that. Let us know in the chat if you were expecting some fireworks or if you were expecting something to go short because of the state of our workshop, and because of because of the way we are soldering stuff by using double-sided tape. Would have been exciting to see some fireworks, no?
I'm gonna grab this cable to flash the code to this.
First up, I want you to like grab the solder iron so we can
Yep, right
make
here.
this connection more stable. I don't know which side the issue is from. Is it from this side? Because I think the solder here is pretty stable. Like it should not be moving around at all. The connection here seems pretty legit.
I think both of the connections seemed good.
Yep, let me double check. I don't think we even have to resolder them. So let me check the.
By the way, just some fun tidbit of information. We have this small BLDC motor as well here for drones and quadcopters. We were meant to use it for one project, but we did not end up using it, so it's still lying around. And the motor driver for this one is a bit different. It's like this. This is the motor driver for this specific motor. It's just lying around at the moment.
Yep, I think
This
these connections are perfect.
All right, right?
Yeah.
Yeah, I guess we can just flash the code.
Yeah, and I don't think there should be any issue with these connections. I think what we can do is we can try to make the connections on the battery side more stable somehow, if that makes sense. And we are gonna keep it this way for now. Let me try and reattach power.
Maybe this is just some standard.
Yep. Yeah, I think we
Sound
need to
recognition
flash the
actually.
code for it to like do something. And also we have not done anything with the USB to CAN adapter. I'm sorry for the camera angle. This might be better. We need to make sure there. So
Let me.
I think I should remove the power when flashing code in there, just in case. So we are gonna wait for the capacitance to run out of the board, and then I'm gonna attach this.
ST-Link server is required to launch the debug session. Let's try this.
Once the hardware part is done, once we're done with the soldering, the wiring, everything, putting together the actuators, I think this is the most exciting stage, the troubleshooting, getting to understand how this motor controller is working, how we can play around with the code, what possibilities we have. But yeah, once we finalize the procedure for this one, it's gonna be exactly the same for the remaining actuators. So the 6C12, it's gonna be working with the same operation. We're gonna upload the same code to all of these actuators, and yeah, I think we can get it working by the end of this live stream, and we will have tested this code on the rest of the actuators before the the next live stream that we're gonna do.
So I'm just having to install some STM Cube IDE software. It's necessary for flashing the code to this motor.
Is that software like recommended by them for this specific motor controller?
Yeah, in the documentation they're using this software to flash the code. I do have STM32 Cube IDE. Okay. Alright, please click here.
So on the other side of things, as you can see, the wires here through this encoder to this motor controller, they are really thick. These are the actual wires that we had to use, we had to solder. These are the wires that are standard for this encoder and this motor controller, and these are 24 gauge wires. We didn't have these wires during the first day when we were doing live stream, so I had to solder a 20 gauge wire, and that was really difficult to do, and it was really messy as well. But we're testing the motor controller with the 20 gauge wire for now, and hopefully I think all the connections are stable. Hopefully this works. But once we make this motor work with the 20 gauge wire, I'm then whenever we turn off this live stream, I'm gonna go back to desoldering everything and replacing all the wires here with the 24 gauge wires. So these are comparatively really thin, and the connections in this case are way more stable, and this is what's recommended. We went ahead and soldered the 20 gauge wire just because we wanted to rush through it, and we wanted to reach to this testing stage as soon as possible. So that's why all the actuators we have right now, where this soldering is done and everything is ready, they all have 20 gauge wires on them. And 2 days later we got the 24 gauge wire, and I have all the remaining actuators for the lower part of the robot's body. They already have these motor controllers and encoders with 24 gauge wire ready for them. So once we figure out the code for this motor controller and we get this motor running, running through this process for the the remainder of the robot's body, it should be a breeze. It should be really fast because we have all the remaining motor controller and encoders ready. With the proper wiring, the right size wiring for this project,
STM32Cube IDE debugger no longer works in Mac OS 15.0, so there's an issue. ST link server is required to launch the debug session. Please download it. So that's the exact error that I'm getting as well. Apparently, letting go from a terminal with sudo solves the certificate with permissions issue. Okay. Had the same issue. You don't need a sudo. It seems to be a path issue. My ST link server is located under user local bin. I guess for some reason the update made it so that the applications do not have this path in their path environment. To locate your ST link server installation in terminal, run this.
Yeah, so we were trying to code this motor controller using a MacBook, and apparently the standard process is for Windows, but I'm pretty certain some sort of process exists for MacBook as well. So we're just trying to debug and we're trying to fix that issue. So I think we're gonna be back in a second once we get everything ready to flash this motor controller. I think while we're debugging, we can increase the sound of the music. Yeah.
No, I think the sound of the music is just.
We can like pause the audio and we can put it to lo-fi mode. Increase the sound.
Alright, yeah, we can do that.
So guys, the issue we're trying to fix right now is we were trying to flash the code using the MacBook, and there's an ST link missing error that keeps coming up, and it's probably because the drivers are not rightfully installed in the Mac when we're installing the STM cube software, and the process is probably I think I have found the root cause of the issue. Just a moment, I'll to install the STM cube, do we have to like log in, or yeah, it's a must. It's a must. You need to create an account. So we have run into a bit of an issue while flashing the software to the actuators, to the motors, and the issue seems to be compatibility of STM32Cube IDE with Mac OS version 15 and upwards. It seems, at least from the discussions that I have read online so far, it seems that it's currently not supported for Mac OS 15 version 15. Yes, Mac OS 15.0 and upwards, it's not supported for them currently. So I am getting an error, and I'm not able to but there is one or two ways around this which we are trying at the moment. So first of all, I'll just try to build this. Build the project. So the build is always successful, and now let's try to run this. Okay, same issue. So what I'll try to do now is we will try to install STM32Cube IDE in a Windows laptop that we have. Okay. And yeah, from there we will then. So do they like send us the link to download? Do we have to like provide an email? I think this is yeah. We do have to provide an email. I don't think we're logged in with any. Can you try logging in with my account over here? Yeah, I think we can, but I don't want to. I'm a bit skeptical. Yeah, with the login on this laptop. What we can do is you can try and share the link with me. Just like, do we have a USB that we can use to? The thing is, they authenticate the link that they have sent you on email. So you will need to open the email over here in this browser. Okay, let's try to then log in with your email. Just try logging it with my email. Yeah. I mean, it's really annoying when you're trying to fix the issue and you're spending a lot of time on the issue, and then every single time you have to download the software just for debugging from their website. You have to give a link to your email, you have to go to your email, verify it, and then you get the link to download the software. It's a really annoying additional step. Log in to my login, write my email, and then you can see the so the email is thing you can do. You can stop the live and make it work with a PC and start the live again with part 2. I will enter it. Thanks for the suggestion, Reg. What we're trying to do right now is we do have a spare Windows laptop lying around, and we're gonna test it on Windows, and hopefully it should work. Like it's a compatibility issue with the latest versions of MacBook. if window does not solve the issue right away, I think then we will have to work on establishing the S3 link. So it's gonna take us like 5 to 10 minutes to test this on Windows, and if it works, that's well and good. We can make sure the rest of the actuators are also working. But if it does not work, then we're gonna think of turning off the live stream, and whatever issue we end up finding with the Mac version and the Windows version, and whatever way we use to resolve that issue, we're gonna mention that at the start of the next live stream. And I definitely have to make a video on this because there's not a lot of support regarding this issue. Most people are doing this on Windows from what I've seen, so I think that will fix the issue. But yeah, I'm just we're working on installing the software on Windows right now, and I'm just gonna give an update in like 5 minutes.
How do you put activate on this thing?
Shift 2. The keyboard format is exactly the same.
I would much rather.
I don't.
It's alright.
I think you can copy.
Yeah. Copying would be
Yeah,
better.
I think I'm just thinking the copying, it does not mess with the special characters or anything like that.
It won't.
Meanwhile, while we're trying to install that software, I'm gonna show you guys something else, something that I'm looking forward to doing in future on this channel. So like I mentioned in the previous live streams, I do often do frame by frame animation, and I really love making animations and illustrations, both of them. So hopefully sometime in the future we're gonna do a live stream on frame by frame animation like this. Let me actually grab the Apple Pencil real quick, and I'm gonna put it to a side. I hope it's visible. I'm gonna turn on the background real quick. Okay, so this is a frame by frame animation I made, and let's try turning the background to a more bright color so you guys have a bit of clarity. And this is Clip Studio Paint, and this is a process most animation studios use this software, and this is a process of making a frame by frame 2D animation. So in this animation, as you can see, every single frame is hand drawn, and the colors, the shadows, everything is painted in frame by frame. And you don't get to this stage right away. So first up, let me show the progress as well. So this is the very first iteration of this. So as you can see, I have made this astronaut character, and she's falling in empty space, and she's first in like this hunched position, and then she opens up her limbs. So this was the first iteration, and after this I moved on to this. So this artwork is a bit more clean, but and the facial expression and everything is more defined. So this will be the second step in making this animation. Sometimes if you're not good at drawing, you can even start with stick figures just to get the body proportions and everything right, but it's a gradual process. Once once I'm confident with this, once I'm confident with this, lol, this is the clean line art. So this is a frame by frame drawing of a clean line art, and then the next step is to add colors, and lastly a shadow, because in the final animation I make there is a background of the universe. She's like in space, so the bright animation was not gonna fit in there, so I added a bit of shadow on her. The final animation is on my social media pages. My Instagram, I have uploaded this animation there. So we're gonna be making animations like this in live stream as well. I have made a lot more anime illustrations and animations like this, and I often do them from time to time. So once we're done with this humanoid project, this is something I'm really looking forward to doing a live stream on.
I think it's about 2 GB of installation. It will take us about maybe 2 minutes for it to download. By the way, the software industry as a whole in its entirety has a lot of issues with the compatibility of different architectures, different versions or updates, and that's kind of one thing that keeps this industry going and alive at all times. So pretty much every new year there are new updates coming with every architecture of the products like Windows, Mac, Linux, all of them, as well as different packages and coding languages themselves, so like Node.js, Python, C++, all of them have updates which keep coming ever. So the field is evolving over time, obviously, and because of that there is always conflicts or issues with compatibility of different things. So even huge code bases like one of Facebook or Google or Uber, Cream, those kind of really big code bases, even they need to be constantly updated. They need constant changes at all time. It's not like one time just setting it up and then it's done. So we have it installed. We are installing it on Windows version. We have the exe.
By the way, like everything, all the other tools in this lab, this laptop also happened to be here just by chance. Good job. It would be cool one day if you could draw the robot animation like this and translate it to the robot's movements. I know it's not possible at the moment. Wait a minute. That seems like an interesting idea. Wait a minute. If you could draw the robot animation like this and translate it to the robot's movement, I know it's not possible at the moment.
I think it's possible.
Yeah, I think it's possible.
Yeah, I don't think I'm pretty sure it's possible.
Yeah.
Like in 3D softwares like Blender, Maya, they have these integrations that can whatever animation you make, like if you make keyframes for your robot, you can interpolate them to a real life robot and track the motion and everything.
Yeah, I'm pretty sure it's possible.
Yeah, a lot of like CGI in movies is made this way, and it's already being used in industry. But the 2D animation frame by frame, we have to make a bridge for interpolating that 2D animation in a 3D software sort of environment. But it's pretty easy to do, especially with the AI tools we have access to right now. We can easily convert this animation frame by frame into 3D.
and it's so crazy to think that that's possible, especially considering AI field was nowhere in the last like
By the way,
4 or 5 years.
for the viewers that are still here, I want to quickly show this over here. So this is a Windows laptop, and while I am installing the STM32Cube IDE to this, you can see this specific thing over here, ST-Link drivers.
Yes, I'm gonna point to it using a solder iron.
Yeah, ST-Link drivers. This is what's missing from my MacBook. Because of this, I am unable to flash the code from my MacBook, which is like a whole arc on its own if I go about trying to debug this and find the compatibility with my Mac OS 15 version. But by when I'm installing it on Windows, by default it is checked, and hopefully it will install this. So this was missing from my MacBook.
Yep, so we're gonna install this and let's see if we're able to push the code or not. I think with the help of AI it's simpler. Yep, Reg, a lot of things are so much simpler with the help of AI. Especially I've been doing frame by frame animation for a while now, and it used to take me weeks worth of effort to make backgrounds for my animation, but these days I really hate a CGI animation, but for the backgrounds I do use a lot of AI tools, open source AI tools like Flux AI. That's really good for making anime backgrounds because it takes a lot of time and it's not worth the effort. For the end result, most of the attention is on the characters in case of my animations. So I can't, like, let's say kids growing up in this generation, when they get used to using these AI tools, they're gonna be when they look back at the 2000s or maybe even a decade from now, they're gonna think of us using making all those artworks, drawing manually. They're gonna think of it like a world before Google Maps.
Yeah.
They're gonna wonder how we used to do things. But especially the anime industry, it's built on the back of so many hardworking animators that work day and night to make only a single background. And there's a really famous scene from a Studio Ghibli movie. The name of the movie is The Wind Rises. It's a really good movie, and there is a 1.5-second clip in that movie where there's an earthquake and everyone is running in the city. That 1.5-second animation scene took them more than a year to make. I think it was like a year and a half or something like that, just for 1.5 seconds of animation, because everything was hand drawn frame by frame. So the industry as a whole, it's built in the back of really hardworking and talented people that really love their craft. But with the AI, of course, there are moral concerns, like AI is trained on the animation and work done by all of these industries and artists, and they never consented to it. They never signed on any documents or anything like that. But I don't see any world where the governments are gonna ban AI for doing that. I don't see any world where the progress of AI is gonna be halted or even slowed down. The big corporations that are working on these AI models and that are building this, they are gonna keep scraping more data. They're gonna keep passing more laws to steal those IPs and animations and content, and they're gonna keep trying to improve those AI models. And common people, plebeians like me, you, everyone, we're gonna keep using these AI systems more and more in our life just to keep up with times, and it's gonna become a bigger and bigger part of our life. So that's the unfortunate reality we're faced with, and every IP copyright stuff in the history that's ever been made, that took.
Yeah. So the comment that Reg made, I think with the help of AI, it's simpler. We're in our mid 20s at the moment, but even we remember when in our childhood we used to have very slow computers like Pentium versions. It would take like 5 or 10 minutes just to boot up and for the window to load. And we have come so far in just these 20 years, in just 2 decades, and I think it's just gonna keep compounding exponentially, and the world in 10, 15 years from now would be very different from the one we're living in today. Even if even when we meet kids today, they're unbelievably more smart. It
Yeah.
always surprises us
Yeah,
how
and
smart kids are.
yeah, and another surprising thing that I realized that's different from the next generation, it's how much they default to using AI for everything.
Yeah.
Like like the way we growing up, we defaulted to using Google to search anything, get information on anything. Their default is AI for now. So the general knowledge or the sort of general expertise of more fields is probably gonna increase a lot in the next generation, just because the search engines or browsers or systems they're using, they are much more smarter, and the creativity or the productivity of an average person is definitely gonna increase for sure by using AI models.
Yeah. So we almost have the software installed. We will.
AI is here to stay. I'm unable to see the comment in the chat. I think live chat. AI is here to stay. If they want to block AI, China will do it anyway, and they know it. But AI will change every aspect of our lives, including robots.
That's true.
Yeah, that's pretty much the summary. Yeah, that's pretty much written in stone at this point. There's no stopping it here. I don't think any government will wanna stop making progress on AI, because the best AI model is gonna have the most wealth concentration. It's gonna have the best surveillance, the best general control uh, over people, and yeah, it's like a race between different governments at this point. Like USA, it's funneling in billions and billions in this AI race, and China is already working at a much more sophisticated level with this state sponsorship, of course, on
Berkeley.
building open source. And even like China is far superior in terms of surveillance systems compared to USA. They try to keep everything under the guise of democracy, like freedom and everything, but China, it doesn't even like try to hide it. So yeah, it's like a race between governments, and I don't see anyone stopping at this point.
Documentation, releases, getting started with the hardware, and flashing the motor controllers. So we need the repository now. We do have the Cube IDE installed.
Yeah, instead of like cloning it using a terminal, you can just go to this GitHub link and download it and place it somewhere.
Yeah. Okay. Yeah. I'll just download it.
Yeah, by the way, like everything else in this lab, like I was saying, this laptop also just happened to be laying around randomly, and it's a broken piece of junk. If I can show you the spacebar key, it's really difficult to get it to work. So this was just lying randomly, like, but I knew it worked, and I knew we would need it at some point, because we're working on Mac, and we have faced a lot of compatibility issues with Mac, between Mac and Windows before, so I just kept it just in case. So yeah, like a lot of other things in this lab.
Yeah. In terms of software and development, my best experience has been on Linux. It's unmatched. you can easily figure out the compatibility issues or conflicts in paths once you get used to it. It just takes like maybe 1 or 2 weeks, a couple of weeks, but once you get a hang of it, it really saves you a lot of time down the years. It's a really good muscle to build up. Firewall, I'll just close this, close this. So we do have okay, downloads and this. So I'm gonna finally load this over here. Import a project. Directory downloads. Extract all. Extract this. I haven't tried Sora yet, but someone in Discord was giving links, invite links for that. And if you have an invite link and we already have a GPT subscription, it's free to use. So I think I'm gonna use that, and if it's just create some fun videos. Yeah, I think the video generation is really good for Sora, and I'm gonna make a video in it. It's getting pretty good. So earlier today we were watching some videos as well, and it took us some time to understand that they were AI generated, and we were shocked. It happened with us today. Okay, select folder. Yep, and a lot of like social media accounts have just started to become AI slow. If we don't like, if the corporations keep doing this and we don't apply any brakes, I wonder what social media is gonna look like in a few years from now. It's like that dead internet theory. Like someone made, I think they wrote an article or something about the dead internet theory, and it was something on the lines of, if AI, you have a lot of AI chatbots online and a lot of AI agents monitoring and making content on social media accounts. So everything you're gonna be interacting online with is AI, and you won't be able to know if on the other end, on that social media post or on that chat log, if it's a real human or not, if it's just an AI. I think this will happen very soon. I think, in fact, it's already happening. If you're using X, most of the posts of famous people, they have most of their comments are botted, completely most of it AI is replies. Just like AI slope, and these LLMs have definitely like added steroids to this problem. It has become pretty common. Who knows, we might be like AI LLM talking to you right now. Yeah, could be trying to get this thing to work. I mean, the video generation has gotten really good recently, that even if we like add a camera, imagine what if all of this is AI generated. Yep. We're getting there, guys. The 3 a.m. sprint session, creepypastas.
provides a newer firmware version of the attached link.
Yeah, they did
Yeah,
mention
give us
that.
whatever version of link is available. Like we really need it right now.
Okay, this
Yep.
one open in update mode.
Oh, the LED just blinked for a second.
Just upgrade, man. Just upgrade at this point.
It's blinking, and that's a good sign. There's a pulse going on over here. This thing is alive. Earlier it was just like beep.
Okay, so you just connected now. Upgrade is successful. I'm just gonna try to run this code once again. Build has been finished and it has flashed.
It's also blinking in green.
It's waiting for debugger connection.
Yep. So we have a new light, guys. We were only able to see red till now, except the power connections. But now the main light, this big one, it's an RGB LED. So we'll get to see some new colors probably.
Okay, it worked. We were able to flash. I think it flashed successfully this time. Let me try this once again. Waiting for the debugger connection.
I think you had to set a flag back and flash again once the flash was successful, right? We had to do something like that.
Yep. So first time boot up flag was 1 for the first time routine, 0 for normal operation. Alright.
Should I attach the power with the battery meanwhile? While we're flashing?
After flashing the initial configuration program, power cycle the board by unplug and plug in again the USB cable, then change the first time boot up flag back to 0.
Okay.
So I will just remove this here. I will change the first time boot up to false, which is 0. Save it again. Attach the motor connections. And yeah, let's run it once again.
We're so back, guys. We're so back. I'm gonna remove this now. And there's something going on. We're getting some new lights on the board.
Voltage is 3.24 volts. Under reset, hardware reset. Okay, so I think it's the code has been flashed successfully.
Okay, so I'm gonna disconnect it from here now.
Yes.
Once you make everything is okay.
Yes. So I
Yeah.
think the flash was
Yep.
successful.
The weather here, it's gotten really cold, and it's the season of festivities is near, and the lights, they really add in for the mood of festivities. Okay, I'm gonna attach this now. It's not like doing anything, but it's just flashing.
Just a second.
Was it flashing earlier when we attached it?
Just a second. Yeah. Initial flashing done. We now need to power cycle the board. For that, just remove this and then make it 0, and that's exactly what
We
did.
need to upload the code again.
Yep. Now we
time boot up and
uh, load ID.
so we have to re-upload the code then.
Yep.
Okay,
Attach this.
very slight detour. Imama varimasu.
Is yeah, okay, this is a 50101.
I wish there was some way to like. We need a holder to put these boards on when we're uploading and stuff.
Okay, so we just have to. It's just a little bit of a software work. We need to.
Just give me the MacBook. I'm gonna place it somewhere else, and you can bring it on the table.
Alright, so it's just a little bit of work for calibration. We've already done the first time boot up. Now to power cycle the board, first time boot up to 0, load ID from flash and load config from flash to 0. Okay. So first time boot up to 0, load ID from flash.
I am gonna
0.
try to give a
Load.
POV of the.
Okay. Load config from flash to
It's
0.
a like really weird angle, so let's just keep it this way.
Load calibration from flash also to 0, which is this, and we also need to select the motor from here. This is 5010, right?
Yeah.
Okay, so we were, I think, flashing for the M6E12. Yeah.
We've got one more like on our live stream, and I think 2 is the most we've ever had on live streams, right?
Yeah.
Thank you so much. We just like dropped a like on our video now.
Woohoo! Congratulations. to us.
Congratulations to us. We're just trying to get these actuators working, and earlier we tried flashing in the code using a MacBook, and we ran into a compatibility issue. You know, if we end up making this work now, you know there's a video coming out today.
Yeah.
For sure, because I haven't seen anyone talk about this, and yeah, it sucks. The different firmwares and the different sort of links or serial communication methods companies use, they don't make a system, or at least they don't actively try to keep the compatibility and system same between Windows and Mac machines. They have their own like proprietary softwares for everything.
The LED is blinking. You can show this over here.
Yeah, I mean it was blinking early on, but
Yeah. So this is part of the initial flash and boot. They are already blinking, and now I'm gonna flash. At least for before calibration, I'm gonna make one final flash.
I really hope the wires below are not short circuited because these are all 20 gauge wires which are comparatively thick and they're not the recommended wires for this module, but whatever, we're gonna try to get this thing working today. Build finish, and now it's flashing. I'm just waiting for the flash to complete, and there we go. So like it flashed for the last time as well. Now I think we can move on to the calibration. Are they keeping the wire attached while not while just so this was the initial boot up of
No,
the
like,
drive
but the
only.
USB is still attached while supplying power from the power supply. I think we can also
Connect the CAN bus of the actuator to the computer through the USB CAN adapter, then power on the actuator. Alright, we will need a Python script. We will probably need a Raspberry Pi. Where's the CAN bus connection on the other end? The other end, it needs to go to the computer.
this
Pi.
one, right?
Not
To
this
the
one.
Raspberry Pi.
Yeah, so the computer which will be acting as a central controller computer for the humanoid robot.
So are you saying we cannot test it?
The thing is that initial flash is successful. We've just not calibrated it yet.
Do we need Raspberry Pi for calibration? Like, is it a must?
Yes. It will help. It will save us a lot of time because once we have the Ubuntu or right setup made inside of that, that will be used. In all honesty, there's some initial work to be done. So we have to label all of these CAN USBs as well. So like 1, 2, 3, 4, as well as separate out all of the actuators. And inside of the calibration, we need to put in those numbers. So it's the CAN 1, 2, 3, 4. Which one is it?
So
Description,
what will
48,
like?
19, and
Can I try like powering it? Oh, okay, so the CAN needs to be like connected. Okay.
Yep.
Have they connected it to like? Can we connect it to this Windows PC?
We would need Python installed, and
I think we can get it set up on our computer. It will take a while, but let's try doing it on this computer.
on what computer?
Install Ubuntu 22.04.
BIOS install
Damn.
dependencies, test connections, read script.
Reg man, I think you were right. I think we'll have to go through this setup process, and then I think we'll once we have everything set up, we'll return to the live stream.
Yeah, once we have the initial things set up, ready for calibration, the environments are perfectly set up, then we can just on the live stream, we can calibrate one by one, because there's no debugging or spending lots of time on the software. We can just calibrate one by one the actuators.
Yeah. Alright, we try to push through this, but it's gonna take a while. The computer shoutout was okay, so we have successfully flashed the code in this micro.
Yeah, that part's done. That's part successful.
In the motor controller, the flashing is successful, so that issue has been resolved. But now we're gonna set up a Raspberry Pi. Let me bring it in the frame if possible. So we're gonna be using a Raspberry Pi 5, and we're gonna be flashing. We're gonna install a fresh version of Ubuntu on this, and we're gonna set up everything for the USB CAN
Yeah.
connection. I think we can just remove it now, and then once everything is set up, we're gonna return and we're gonna test each actuator one by one. Yep. So that's where we're at. It'll take us like 1 to 2 hours to set up
one
everything
to
up.
2 hours to set everything up and label all of the CAN, USB, and actuators.
So yeah, hopefully the next live stream won't be just a
Yep.
debugging session. There'll be some actual progress in there. We'll make sure the environments are set up before we start sprinting on the next
Yep,
one.
but debugging is part of the process.
It's part of the
yeah,
process, yeah, obviously.
I'm glad we got it a bit on the live stream as well. But tomorrow's live stream is probably gonna be much longer. And once we have all the environment and everything set up, we have all the actuators just lying around ready to be tested. And in the next live stream, we're gonna try and push for 5 hours at minimum, and we're gonna start the assembly of the robot. So hopefully by the next live stream, we will have the upper body of the robot ready. So thank you
Alright,
so much,
yep.
guys. Thank you, Reg, especially for keeping the chat engaged. We're gonna end the live stream here, and we're gonna move on to setting up the firmware and getting everything ready. So in the next live stream, we don't run into any firmware pushing issues or anything like that. So yeah, see you guys in the next one. Once again, thank you so much for joining our stream. And yeah, in the next live stream, we're gonna be working on the upper body of this robot, most probably. And the next live stream will hopefully be much longer, 5 hours at least.
Yeah, it will definitely be longer.
Yep. Okay, thank you so much, guys, once again. And I'm gonna log off now. See you guys soon.
Yeah,
Cheers. Bye bye.
bye bye.